Okay, so let's look at these. I don't know if they're going to ask you this one, but they have in the past, and it's kind of a straightforward one. If you've got inverse functions, and you want to find the derivative of one of them, you know that the derivative is 1 over the inverse function's derivative, but not at 3. You have to find where f's output is 3. So there must be some clue here. So we know the output, so we have to evaluate g at 2. Or f at 2, sorry. Well, that's 1/8. Okay, now here's the next one. So for sure they're going to ask you something about limits. Let's see. The default is you put in the number, but if we did f of 2 minus 2 minus 1, f of 2 is 3, and 4 minus 4, so we get 0 over 0. So the very last thing we learned when we weren't together is one way to evaluate this is you can use L'Hopital's rule to get a new function with an equivalent limit, and that says take the ratio of the derivative. So this would be f prime of x minus 1, the derivative of -1 is 0, and this would be 2x. And now you're going to try the same thing again. You're going to try and put 2 in there. So it's f prime of 2 minus 1 over 2 times 2. F prime of 2 is 8. So this is 8 minus 1 over 4, which is 7/4. Okay. And we were very first together. The whole reason you do limits is because you kind of want to describe functions. So this is a vertical asymptote. That happens when, as you approach 5, you want the outputs to approach infinity from one direction or the other. So the only way that's going to happen here is if the denominator is 0. So let's set x plus 2c equal to 5. Oh, sorry, not this. We want it equal to 0, and where x is 5. So we know 2c is -5, which means c is -5/2. Okay, and you get, let me change color. You get a horizontal asymptote when, as you're approaching infinity, you get some number. And we want that number to be 7. Okay, so let's see. So this function is a rational function. So the end behavior is like the ratio of the leading terms. So the end behavior looks like D, but we want that output to be 7. Okay, one more. Okay. This is my favorite. If it was me, I for sure would ask you a question about the derivative in disguise. So you're like, that is the derivative. That thing is f prime of x. And sometimes they'll put a number in here, then it's f prime of a particular value. But in this case, this is f prime of x. So we know the derivative for the function we're looking for is 2x plus 7. So we can work backwards and find the antiderivative, which would be x squared plus 7x plus some constant c. And they gave us a point, so we can figure out what the constant is. 6 is 1 plus 7 plus c. So 6 is equal to 8 plus c. C is equal to -2, which means f of 2 is 2 squared plus 7 times 2 minus 2, which is 4 plus 14 minus 2, which is 16. Yay.